Hi, today we're going to talk about latency. Ideally, we'd be pushing our applications directly to the laptops, cell phones, and devices that would be using it. But for most of us, we're creating websites and delivering that content over the internet. And that network can create a certain amount of latency. To try and decrease that latency, I deployed my code to over 400 servers. The question is, did it help and is it worth it? Before we get into the details, if you want to learn more about the intersection of e-commerce and technology, you should hit follow now. My name is James, and I've been spending the last 20 years building e-commerce websites. And over those 20 years, we've all known that speed is king. Site speed is directly correlated with improvements in conversion rate. So you need to make that website as fast as possible. And I've tried every technique in optimizing it, from improving the website code itself to the infrastructure that it's on. And now my next step is trying to get that code closer to the end user. And to do that, I deployed it to over 400 servers. So, did it work? Well, short answer, yes. It improved latency. Depending on where I pinged the server from, it improved it by a lot. But due to my lack of billionaire status, I didn't pay for 400 rack servers across the globe. Instead, I used the new thing called edge computing, and I leveraged AWS Cloud. So, being a fan of serverless, I deployed two versions of my code. One as a standard function, the other leveraging CloudFront's Lambda Edge. This allowed me to compare the latency of both options and decide if edge computing is just a marketing fad or if it's going to be a real game changer for e-commerce. So what is edge computing? A normal serverless function, container, or virtual server is set up and deployed to a specific region, like US East or Canada Central. And that region will include multiple physical locations or availability zones, ensuring we get amazing uptime. But they are each clustered in a specific geographic area. They do this on purpose so that as data moves in between the different locations, it stays at a low latency amount, so that data can be synced live without slowing down the overall system. This creates a reliable system and can be incredibly fast, but if you call that code from a faraway location, you end up with increased latency. So for example, if you're calling your servers in New York from California, that's 3,000 miles away. So even at the speed of light, you're still adding 32 milliseconds to the round trip. But in reality, the internet's infrastructure, the actual backbone, it's mostly high-tech fiber optics. The last mile might include copper. Maybe people are on wireless connections. And believe it or not, there are still people on dial-up. So in the real world, we're looking at at least 85 to 100 milliseconds of added time when crossing the United States. And that doesn't even count crossing into other countries or across the Atlantic or over to Australia or other parts of the world. So with content, we've solved this for a long time with content delivery networks. What we do is we take our static assets and we create a cache in all of the CDN's hundreds of locations around the world. And then when someone looks to pull that static asset, it comes from the cache rather than going back to that origin server. Edge computing takes the same approach, but instead of just images and static files, you can deploy your function, your code, to those same locations. So how much faster was Lambda Edge compared to a standard serverless function in a single region? My test showed an average of 1.6 seconds of improvement when tested across the world. And that difference varied greatly depending on which location you were calling from. So if you were calling from a location really close to that origin server, it was still very fast. If you were calling from the other side of the planet, it was extremely slow. So edge computing solves all of our problems, right? Well, not exactly. Unfortunately, we can't deploy everything to the edge. So the major edge computing options today, AWS, Vercel, Netlify, Fastly, they all place strict restrictions on what you can run. So you can't have full servers, you can't have containers, you're not really going to be pushing data to the edge. Instead, we're limited to small functions, typically written in JavaScript. So that's what you're down to. And it makes sense. The fact is, syncing your database to this many locations would be really expensive, and all of that syncing would be slower than just having a single location. The overhead would just, make your database unresponsive. So now the question is, with all of these limitations, is it even useful? Does it make sense for anything to use this edge computing system? Or is it really just hello world and a marketing push? So as I looked at the limitations and I looked at what you can and cannot do, I realized that for composable commerce, there's a single use case that makes a lot of sense. So a popular pattern in composable commerce is to build a backend for front end, maybe an aggregator service, or a set of microservices to sit between your SaaS APIs and the front end. So for past projects I've worked on, we've done full Kubernetes deployments as that middle layer. That allowed it to scale and keep up with the high-end SaaS platforms that we're using. We adopted, for some projects, we looked at serverless because that could limit the amount of code and maintenance, but it did suffer from cold starts, and as we know, speed is money. So how does edge computing play into this role? Well, it comes with major benefits. In addition to that low latency that we already talked about, reliability and scale is built in. There is no infrastructure to manage, and the code will auto-scale based on demand. This also comes with the same cost benefit as serverless solutions in that you only pay for what's used. So it really makes sense as your BFF layer, as that small area where you want to add in some logic outside of your APIs. So while you can deploy these edge functions individually, like I did to AWS Lambda Edge, there's better ways to do it today. The newest versions of Nuxt.js, Next.js, and SvelteKit have this baked in. You can use these platforms to deploy APIs, middlewares, and even doing all of your pre-rendering directly in these edge functions. So whether you're using React, Vue, or Svelte, you're all set to go. In fact, Elastic Path Commerce Cloud has a new direct-to-commerce starter kit, and it's built with Next.js 12. So this allows any e-commerce companies adopting the starter kit to take advantage of all these new features. So you combine this edge computing with the guaranteed 100 milliseconds response time, and you get a super fast composable commerce solution. So if you want to see all the details, the stats, and everything that went on with my test, I'll put the blog post in the description. And let me know in the comments if you plan to use edge computing for your next project. Thanks everyone. Have a good day.